Hello everyone, yeah, I'm Paul. I am a member of technical staff at Anthropic. I'm one of the MCP core maintainers. I work in the Auth working group and the member maintaining Auth in the TypeScript and Python SDKs. So I'm going to be talking about why is MCP Auth hard. I think that comes up a lot is the problems people have with it, the friction that in implementing it, and what are we going to do about it. So to start things off, I'm going to do the standard MCP talk, which is talk about what is MCP and why it is. I promise that this serves a purpose, but it'll be my special version of this. Also, this talk is unofficially sponsored by Excalidraw. So in the olden days, pre-LLMs, if you want to make a calendar app, you would make some custom code to talk to Google Calendar. If you wanted to talk to a single resource like a calendar. If you then expanded your application to talk to a bunch of different things, you would have to do a different integration for each of these different resources. So that means a piece of code in your application, you have to handle the inputs and outputs of each of these APIs. You might even be using a specific SDK for Calendar or Outlook or one of these different servers. And now we are in the magical LLM world where we have these general purpose clients where the LLM can handle random inputs and outputs without needing to know about it beforehand. And so we just have to do the one MCP integration, and we get to connect to all these different resources. And the key thing here that I want to talk about from the auth side is that it enables a client to talk to a resource that has never seen before. So not even that the client developer didn't have to do any code, but the client developer might not even have known that this thing exists, and there is definitely not any pre-existing trust relationship between those two entities. Okay, so what are the challenges that introduces? And I'll be talking specifically, focusing on HTTP remote MCP servers. There's other angles on it, but that's what we're going to be mostly talking about. So going back to the pre-LLM world, if I was developing this application, I would write the code for it, and then I would go and register with Google and get an OAuth client ID in secret. During that process, Google will be collecting app information from me, confirming my email, checking that the app actually works. They can make the process as onerous as they want. Then we go through the standard OAuth dance where the user discovers my app, they visit it, my app sends them to authorize with Google. The user consents to my app accessing their calendar data, and then the calendar app accesses that data. And so what this pre-MCP flow relies on is this strong bilateral trust that comes from the registration up front. And because there is that strong trust, my calendar app knows that it's talking to the real calendar, and the calendar knows something about my app because I've done all this work ahead of time. That means that you don't have to worry as much about other legs in the flow. Things just kind of work in a high trust way. So going back to our LLM world, where for each application, that also meant that each developer would need to go through a pre-registration flow for each of these different resources that they want to access. And now in the MCP world, it would be a lot more noticeable if you had to go do that pre-registration flow because you're not having to write the code for it. So it's like, why would I also then have to go do a big onerous onboarding to enable that? So back to our MCP flow, rather than the user discovering my application, they're already using a general purpose MCP client, so like my chat app. Then they discover an MCP server, Google Calendar MCP server. My app sends them to authorize with Google Calendar. The user consents to the chat app accessing the Google Calendar data, and then my app gets the data. In this case, we don't have that pre-existing trust. Got these big bars through. There's no registration that happens ahead of time because we're doing dynamic client registration. And without that registration, we have a weak trust relationship between the chat app and the calendar. And that's kind of this fundamental conceptual difficulty that we have with MCP Auth, where we want to enable this generic access between clients and servers that have never seen before, We don't get to lean on that initial trust, but then we want to prevent bad things from happening in this scenario. So what are some bad things that can happen? You can have a bad client. So with this dynamic nature, it's easy for a bad client to register with a good server and then send you a consent link. And if you're not paying attention, you might grant access to that bad client. You could also do a bad server, where a server poses as a legitimate calendar server, and maybe they slurp up some data from you from your chat app as you're just expecting it to send it to the real server. And then the last one is the trickiest one, where you have a man-in-the-middle attack, where someone ends up putting a good server, or poses as a good server. The user actually ends up seeing a real authorization consent link, but that token ends up at the man-in-the-middle server, which is serving as a server and a client in the middle there. Okay, so brief aside, a lot of this has been talking about OAuth, and that's like kind of the things I'll be talking about the rest of the talk too, but I wanted something that comes up frequently is like, what if we just did API keys? If we just included, during the pre-registration step, you can also just get an API key. You could get a URL from Google Calendar that has like an API key in it. And the reason why we're going with OAuth and building on top of that rather than starting from API keys is that with OAuth, we get a lot of flexibility and a lot of places where we can hook into things. So if we have a consent screen, we know that the user at that moment consented to it, where an API key is generally long-lived and usable across different applications. And then also it's more difficult to revoke an API key without breaking legitimate usage, where if you have OAuth credentials, it's easier to revoke. So brief aside on API keys. So given that we have this situation where we have this weaker trust relationship without the registration, we want to prevent those bad things that I just pointed out, but also keep this good, smooth UX of being able to connect clients and servers that haven't seen each other before. Also, before we jump more into this, if the client and server do know each other before, if they can register, that is a perfectly viable option, and it's generally a pretty good option sometimes. I know this comes up sometimes in MCP where it feels like I need to do dynamic client registration. I can't do a pre-registration, but that is often a very good option. Okay, so that's the conceptual problem, is this weak trust between these unknown entities. So I'm going to talk about why it's hard in practice. So the first thing that's difficult is that there's just a lot to implement. In order to get the dynamic access you want, and then also these mitigations, we have to add a lot of, or implement a lot of different pieces of this authorization flow. So here I have a pop quiz for you all. I hope you all came prepared. I want you to match the RFC with its title. And then we'll raise your hand. I'll show you the answers, and I want you to raise your hand if you got them all right. Okay, are we ready? Everyone have their answers locked in? I see some intense looks. I'll give another 20 seconds. Okay. Okay, raise your hand if you got them all right. Yes. Anybody? Anybody get half of them right? Did anybody get any of them right? Okay, somebody got somebody right. Okay, good. So the thing I'm trying to illustrate here is there's a lot of RFCs that we have to follow in order for this dynamic flow to even work. Some of them, like the metadata, is just to enable the servers to be able to talk to each other at all. And then some things like resource indicators are for preventing some of these man-in-the-middle situations and attacks. So because there's so much to implement, that also means there's a lot of room for incompatibility. It means if you can implement your metadata in a couple different ways, then that means that if your client implemented it one way and your server implemented it another way, they're not going to be able to talk to each other. So here's the list of things that we are doing to address this particular one. The first one is conformance testing. We're also working on pluggability in our SDKs to be able to swap in different implementations and make it easier to extend. We're going to update the inspector. The inspector has lagged a little bit behind the very cutting edge of the draft and has some inconsistency between the generic connect and debug connect. And then we're also working on some live examples that people can test their clients against. Okay, so real quick, the conformance testing, a step is pending for this, but it's the idea that we'll have a golden server that then an SDK client can run against, and we'll have the golden traces to compare against. Then similarly, we have a golden client that will connect to an SDK server. This means that once we've recorded those traces, it's much easier for SDKs to know if they are implementing these features in the same way. So we can have less confusion about did I do the metadata path order correct, or did I spell the resource parameter with a trailing slash or not? All these kind of questions that come up. Pluggability in SDKs. Yeah, so this is near and dear to my heart. Is in the inspector, we have the TypeScript SDK, and we also have a debug implementation, which tries to use as much of the TypeScript SDK as it can, but there are places where we have to kind of work around that. Which means that anytime we change a TypeScript SDK, the inspector can then break on existing auth flows, or it's just like slightly, you'll get inconsistent behavior in one place or another. So we're working to make the SDKs more pluggable. In TypeScript, we have a middleware pattern that we're introducing, so we should be able to wrap the existing auth flow with a debug middleware that then lets us inspect the calls that are being made and expose that information rather than having to try to maintain these two parallel implementations. And so Inspector is kind of our golden client in a way of like, if it works with Inspector, there's a pretty good example of what it should work with in other clients. And then the other end of this is, can we make golden servers for people to connect to in a couple different configurations to illustrate how those should work. So a couple different authorization configs, and then also the kind of everything server as a utility to connect to. Cool, okay. So difficulty number 2, as dynamic client registration, DCR, is painful. I want to be clear that DCR plus MCP is the painful thing. DCR is it's an old RFC. It's been around a while. Like the thing that is painful about it when it's used that way we are using with MCP is that it was not built with MCP in mind. So here's the DCR flow. Up top, we have the client registering with its callback URL. The authorization server gives it back a client ID, stores that in the database with the callback URL. The client then sends the authorize request with that client ID. The authorization server knows to send the callback back to that same URL and can check that. And then we do the exchange where we exchange the authorization code for the token. So the 3 pieces of this that are not designed with MCP in mind. The first is the database. So the scale of reads and writes to these databases, like normal client registration flows we talked about before, where you might have a whole back and forth with someone, making sure that their application hits your standards before you give them a client ID. That's the kind of like time scale for that a lot of these databases are built around. Whereas with chat apps, they might just hammer your DCR endpoint with client registrations, and it's hitting a database that was like not really built for scale. And so this is the existing implementations that you can say, oh, we leaned on. One of the reasons why we picked DCR was that it had some existing implementations to lean on, but it turns out those implementations aren't really built for the scale. So it's not just an easy flip on DCR and then you're supported. The second place where this kind of breaks down is, this has come up earlier today too, is the expiration of these databases. So because there isn't a clear semantic around expiring client IDs or how long you should keep a client ID, eventually, unless you want your database to grow unbounded, you need to start purging them. And then once you purge that client ID, you end up in this really bad situation when you're trying to refresh a token or start a new authorization with a expired client ID, because you don't have the redirect URL anymore, which means that if you just follow through with the callback, even if you just want to send an error code, that's an open redirect, which is another security vulnerability that you don't want to introduce. The last way, this is not built with MCP in mind, is the client screen of all of my authorized clients. It becomes a huge mess with DCR because you might have 10 clients registered for the same application, just the way that it kind of worked out, or the different implementations are, which also makes it not very useful for people to actually control access to the applications. Okay, so what are we doing about this? This is SEP 991. It's pending. Should be going to review soon. This is client ID metadata documents. So this is a pending IETF draft. The idea here is instead of doing dynamic client registration, you put a URL to a metadata file in as your client ID. Then the authorization server fetches that metadata file to get the application information, including the redirect URI. They can store it in a database for caching, so they don't have to fetch it every time if they want, but you don't have to have a fully unbound database for this. And then the client uses that same URL as its client ID throughout. So yeah, this is great for a couple of reasons. It fixes those three things I pointed out before. You don't have to have a big unbounded database. The database is just for caching, so it doesn't necessarily need to be the same same database that was intended for very low writes. And then the client screen starts to make sense again because the ID is a metadata URL, which should be recognizable, and it should be one per application. So yeah, if you have thoughts on that, SEP 991 is your go-to for that. Okay, so the third difficulty is even with everything we've talked about so far, all the RFCs and mitigation stuff, we still need more trust. There is not, we haven't fully solved this weak trust problem. So there's a couple things that we're doing to address that. The first one is the registry API, and more of we'll get into it a little bit more, but yeah, the registry, there's more mitigations and protections we need to add to the core spec. And then we want to lean more into optional extensions for even more protections that are more relevant for enterprise scenarios or when you have different things available to you, like a certificate authority on your client. Okay, so going back to just talking about the registry for a second, two of these bad things that can happen. So these attacks rely on a bad URL being selected by a user and inputted into a chat client. If you have a registry that has strong moderation on the servers that are allowed into it, then you can reject those at the moderation level, and then they'll never get into the rest of the flow. I want to be clear here that this is probably more relevant, at least immediately, for people using the registry API and deploying their own registries. The official one that's deployed now does not probably have the level of moderation and restrictions that you would want for an internal corporate environment. So you can think of it kind of like how you would have your own Artifactory or maybe your own NPM directory internally for listing URLs. So with that, if you're able to if you have this trusted source of URLs, then you prevent a lot of the risks there. Okay, the last difficulty I'm going to talk about is the second hop. What I mean here is that it's pretty common for an MCP server to then go access additional resources that aren't served over MCP. They might be served over HTTP or SOAP or SAML or XML, whatever you want to do. So this first hop is from the MCP client to the MCP server. We have our authorization server for that connection. That's well defined in the specification, and that's where we put a lot of energy in. This kind of second hop to these other servers is not really under the governance of MCP at all. It can be whatever you want. The one mention of that we have in the spec is that we don't want to do token pass-through. So you don't want to use the same token and pass it straight through to that other resource server because you end up with some token leakage risks there. So the difficulty that presents is that it adds another layer of complication. Even when you're starting to talk about auth and MCP, that's the first question you have to ask is which connection are we talking about? Are we talking about the client to server connection, or are we talking about the server to secondary resource, this second hop connection? And there are very different problems and very different solutions to it and very different things available to them. So what do we need to do there is just have some better examples and guides on how to do that. For the if you want to do it on behalf of Flow, you need to have a token vault. We need to have examples and show you how to do that token mapping in a way that works. Again, since it's not in MCP, it's not going to be in the SDKs, but we need examples about how you would deploy that in a reasonable way. Okay, so recap. MCP Auth is hard because we want to enable general purpose clients to connect to resources they haven't seen before. That's the big conceptual thing that's hard to do, and but also very powerful if we can get it right. There's a lot to implement to make that possible. DCR was not built with MCP in mind. We want more trust and defense in depth than we have today. And then that second hop just adds more complexity and confusion when people go to implement it. All right, to close out, MCP Auth needs you. We are the Auth interest group in Discord. If you're not in the Discord, the invite link is in modelcontextprotocol.io. I've heard that people get confused about the Discord situation. There is a community Discord and there is the contributor Discord. This is in the contributor Discord. So if you're, feel free to come find us over there. So if any of these things interest you, please come talk to us. Conformance tests, a feedback inspector, client ID, metadata documents, extensions, and then also would love help writing examples and guides. Thank you so much.